Hello friends, this video on Binomial Theorem part 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched Binomial Theorem part 1 to part 4. Now let's take some special case of Binomial Theorem. X minus y to the power n. So if you see, the normal case we have developed was a plus b to the power n. And this is x plus x minus y to the power n. So what we'll do here is, we'll replace a with x, or replace a with x and b with minus y. So if you see a plus b to the power n, this guy is equal to nc0 a to the power n b to the power 0, nc1 a to the power n minus 1 b to the power 1 dot ncn a to the power 0 b to the power n. So here we are replacing a with x and b with minus y. So x minus y to the power n, this will become nc0 x to the power n b to the power 0 is equal to 1 plus nc1 a to the power n minus 1, that is x to the power n minus 1, replacing a with x, and b is to the power 1, b is equal to minus y to the power 1 plus ncn a to the power 0, that is x to the power 0, into b is equal to minus y to the power n. So this guy becomes nc0 x to the power n. This becomes minus, because minus y to the power 1 is equal to minus y. This becomes minus 1 nc1 into x to the power n minus 1 y plus, and this becomes minus y to the power n minus 1 to the power n into nc n x to the power 0 is equal to 1, and this becomes y to the power n. So if you notice, the difference here is you get alternative minus plus. This is nc0 x to the power n minus nc1 plus nc2 minus nc3. So there is an alternate pattern. If you see the coefficient, this becomes nc0 plus minus nc1 plus nc2 minus nc3 plus nc4. So this is the pattern you get in x minus y to the power n. So typically x minus y to the power n is equal to this. The only difference here is, in this you have alternative plus and minus. So we have one more special case in binomial theorem, and that is 1 plus x to the power n. So if you notice, a plus b to the power n is equal to nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 ncn a to the power 0 b to the power n. Here a is replaced by 1 and b is replaced by x. So here when we say 1 plus x to the power n, so we can also write this as form nc0 1 to the power n is equal to 1, b to the power 0 is equal to 1, nc0 is also equal to 1 actually. So we'll say 1 plus, this becomes 1, nc1 into a to the power n minus 1 is equal to 1 to the power n minus 1 is equal to 1. This becomes b to plus 1 plus nc2 a to the power n minus 2 is equal to, here replacing a by 1 we get 1 to the power n minus 2, that is also 1. So this becomes b square ncn b to the power n. So you see here a term is gone, only we have term b. Sorry, b is equal to x here. So what we'll get is nc0 is equal to, okay, I'll make it nc0 only instead of 1. So this you get nc0 plus nc1x, replacing b with x here, plus nc2 x square plus nc3 x cube plus nc4 x4 ncn x to the power n. So you see the pattern here, a is gone because a is 1 here. So the pattern is nc0 x to the power 0, nc1 x to the power n, nc2 x to the power 2, nc3 x to the power 3 dot dot dot. So these, you need not remember all this pattern. If you remember this formula is more than enough. This formula, if you remember, is more than enough. But if you want to solve this question fast, then you need to remember these formulas, because these formulas help you to solve the question fast. Generally you get formulas like this only, 1 plus x. So instead of writing this big formula, you can write this shorter formula. It gives nc0 plus nc1x plus nc2x square nc3x. Similarly, we have one more special case in binomial theorem, and that is 1 minus x to the power n. So here also you see, instead of x we have minus x. So in this formula nc1 plus x to the power n, which we have derived now, we have got nc0 plus nc1 x to the power 1, here it's x to the power 0 actually, plus nc2 x to the power 2, here you got nc3 x to the power 3 dot dot nc and x to the power n. So if you replace x with minus x, this becomes nc0 x to the power 0 minus x to the power 0 plus nc1 minus x to the power n 1 plus nc2 minus x to the power 2 plus nc3 minus x to the power 3 dot 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 ncn minus x to the power n. So you observe here that all the even powers of x minus x square minus x4 minus x6 becomes, and this is 1, this is 2, this is 3. All the even power becomes positive. So this becomes minus x to the power 0 is equal to 1. So this becomes nc0. This is minus x to the power 1 is equal to minus x. So it becomes minus nc1x. This is minus x to the power square is equal to x square. This becomes nc2 x square. This again becomes negative, because minus x to the power cube is minus x cube dot 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 minus 1 to the power n into ncn x to the power n. So here what I have done, minus x to the power n I have done as minus 1 to the power n into x to the power n. So you get this formula. So here where you have alternate plus minus, and this is a special case. You need not again remember this, but it's good to know. If you know this, you can solve the question in faster way. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.